finally. Okay, my name is Mikhail Sveshnikov, as Jenny said, and I'm MLEM lead developer. Probably we don't have like proper titles here, but yeah, today I'm going to tell you about MLEM, our new open source tool. And here's the agenda for today. First, with this little presentation, I will tell you what is MLEM and why we did it, and also what you can do with it. And then I will give you a little demo with the Jupyter Notebook, how you can use MLEM in real life with the real code. Okay, so what is MLEM? MLEM is obviously a famous internet meme when your pet is sticking your tongue out. Yeah, of course, I'm joking. MLEM is our new open source Python tool. It provides easy and flexible way to package and serve your machine learning models. We transform your models into Python modules or into Docker images or some other way of packaging your models. And we define standard interface and formats for models and datasets. And it has modular and flexible design. Basically, it can be customized by anyone. Right now, we support almost every famous machine learning framework for models or for data, but we will support more in the future, and everybody can contribute their own implementations, of course. And also, we provide an easy way to deploy your models to some cloud infrastructure. When I worked as a data engineer / MLOps engineer, one of my responsibilities was to take models from data scientists and make them work in production. This means that I have some existing infrastructure, some existing systems, some existing microservices, and I need to like integrate a model into the system. And I wrote a bunch of wrapper services for models and integrated them. But basically, all of those wrappers were pretty much the same. I mean, it's like you spin up some Flask application. It has like predict endpoint, and you load the model, and you deserialize the data frame, you feed it to the model, you get the response, you deserialize response, and that was exactly the same for all those wrappers. The only difference was like which model do you load, which features it expects, and so on. So I thought to myself that since I'm very lazy and I don't want to do repetitive work, I should automate this. And what came out of this is basically MLEM. But to be able to serve and create services from your model, you need to know a lot about it. For example, how do you read the binary file to get the Python object? What are requirements for this model? Which frameworks do you use? Which environment variables you need to set, and so on. And of course, you need to know which methods does this model has, because for different frameworks, there are different names of methods. They have different signatures and so on. And signatures means not only like the name of the method, right? It also means the list of arguments, their types, the schema, and the way to serialize them and deserialize them back to JSON or whatever protocol you are using. So I don't want to provide this manually, all of those things. So the only way to do this automatically is to intercept live Python object, I mean model object, and inspect it before you save it. And from this, you can learn all of this stuff. And MLEM does exactly that. So there are two parts of MLEM. First one is about codification. It's the step when we take your Python object and we extract all the metadata I explained just now. And then we save your model as some regular binaries. I'm meaning like pickle files, some weights files for neural networks, and so on. And an additional .mlm file, which we call metadata file or meta file. And with this file, we say that now we have a MLEM object created from your model. And using those MLEM objects, we are able to create packages, serve your model, and deploy it to the cloud, and basically use it in different scenarios for deployment. So what is MLEM object? MLEM object is created, as I said, from live Python object, assuming like model is a fitted model from scikit-learn or from some other framework. And we have a simple API command, which is save. It's mlem.api.save. And you just provide your model object and path where you want to save it without any additional environment settings or something like that. And this will produce two files. One of them is a model.mlem, and it's a YAML file that contains all the metadata, the information about framework, about methods, signatures, requirements, and so on. And the binary. In case of scikit-learn, it will be pickle binary. In case of, I don't know, XGBoost, it will be XGBoost produced binary. So we have separate implementation for each library, basically. And also you can save data sets the same way. And I will explain later why it matters. Kind of secret, but of course we cannot think of one single scenario for each project. So we want MLEM to be very flexible and customizable. That's why we have a plugin system in place that will allow anybody to add their own implementations for machine learning libraries, for serving logic, the packaging logic. Basically, any part of MLEM can be customized. And actually, all the built-in implementations that we have are also plugins. They're just like they shipped with MLEM code base. So you can either create your own package, which will be MLEM plugin, or you can contribute it to MLEM repo if you want. Yeah, and a very important thing to say is that MLEM is designed and built with GitOps approach in mind, like other tools from Iterative. So using iterative tools together will get you even more GitOps goodness. For example, you can use 𝘺𝗶𝗵𝗍 to version your model binaries, and thus you will not pollute the Git tree. Also, there are MLEM CLI commands that you can use in 𝗺𝗶𝗵 pipelines if you use them. Also, we have this less known tool called GTO. It allows you to tag your files and versions of them in Git repository and promote these versions between different environments. I mean, like staging, production, and so on. And using this with MLEM will basically get you full-scale model registry. Like, for example, you have in MLflow, but in our case, it will be GitOps model registry, since you don't need any other databases and servers being just your Git repo. And of course, we have Studio, which will show you in a nice UI all of your models, all of your artifacts, and so on. You can actually read more about this model registry at the link that is not seen here, but it's, yeah, we should provide the link in chat probably. Can we do that?
Done.
Nice, thank you. Okay, moving on. Now I will tell you what MLEM can do. So we'll start with the typical MLEM workflow. So first you train your model like you always do. using one of the supported frameworks. And then you just save the model, as I explained before, with MLEM API save, and you turn your model into a MLEM object. And then we've got a bunch of question marks and profit. And in Dogolingo, question marks means exciting stuff. So I will tell you about all the exciting stuff in ascending order of excitement. So the first level is plain loading. Of course, if you saved your model, you can load it. And for that, we have MLEM. So I will just repeat the slide, right? The first level is plain loading. If you saved your model, of course, you are able to load it back, and you will get exactly the same object that you saved. And you don't need to specify framework or something like that. You will just get the same object. And it's framework agnostic, meaning that you can save any object that we support, and you will get back the same object, basically. We support remote URIs, meaning you can save your model directly to S3, for example, and load it back from S3 without copying locally. Also, we support GitHub URLs. That means you can load some model directly from GitHub. And we support revisions, so you can specify which commit you want to use, or which branch or which tag in the Git repository. And of course, we support 𝘺𝗫 tracked files. If your model binary is in 𝘺𝗫 cache, we will get it from there for you. Also, we can check that your environment where you're trying to load the model is compatible with what model expects. We can check all the versions of the libraries, Python version, yeah, and stuff like that. So if your model doesn't behave like it should, you can check whether you're loading properly in the proper environment. The second level is applying. Basically, you're using the apply method from API or CLI to quickly run your model against some data. It's almost the same as just load your model object and just use one of its methods, right? So it has one of the first level tier features, but MLEM also will handle loading the model and data, and you don't need any code if you use it from CLI. Next level is serving. It's when you spin up some online serving process for your model, and you don't need additional setup or code for it because it's already done. We automatically convert your model methods into HTTP endpoints or some other kind of endpoints. We automatically serialize the requests and response. If you're using FastAPI, for example, you will get nice OpenAPI schema, and we'll see that today. We also have a RabbitMQ implementation, which is a messaging queue for different scenarios when you don't need an HTTP endpoint. And we're going to add some others soon, like gRPC, maybe, I don't know, Kafka. And actually, you can suggest which type of serving do you need, and we will think about how we can implement it. Next level is building packages. And this is basically about exporting your model to some other format or packaging it into package. Yeah, so right now we can turn your model into pip package, and you can install it, and it will have functions that corresponds to your model methods. And also you can build a Docker image together with the server from level 3. This Docker image will have the server inside, and then you can run it somewhere for example, locally or in some VPS or somewhere else. And of course, here we also want your feedback, which implementations for building packages do you need. Next level is the most exciting. It's deploying to cloud. So basically you describe your target environment, for example, your account in some cloud platform, and with like one API or CLI call, we will spin up serving in this cloud in your account. And of course, you also don't need additional setup for this, and you don't need to go through cloud console interface or API, and you'll be able to check your deployment via MLEM API or CLI also, and you'll be able to make requests to deployed model, and from the code it will look like your model is local. I mean, you will get this client object, and you will it will have the same methods as your model, and you need to call these methods with the same arguments as your local model, for example, with the pandas data frames or NumPy arrays, and it will give back you the responses of your model. Also like NumPy arrays or whatever your model returns. But actually what happened was your data was serialized, sent to the cloud, then the model executed and get the response, get the prediction, and it was again serialized, sent to you, and deserialized locally. Yeah, and this level 5 deploying to cloud is so exciting. So it's still considered experimental, and we will work on it more in the upcoming months, I guess, and we will make it even better. So yeah, it's almost demo time, but first I want to share some future plans with you. Of course, we will fix existing bugs that we find, and maybe some of you will find. And while doing that, we'll add new bugs, so we have something to fix later. We will add support for more model and data types, more packaging formats, more serving protocols, and more cloud platforms that we support. As I said, we're going to work heavily on the deployment. So to get rid of this experimental tag, and yeah, probably some more exciting things that we don't know yet. Okay, and now we're ready to go to demo part. Are there any questions for this one?
Any questions before he starts the demo? Alexander, go ahead.
Yeah, I was just wondering, thank you for the presentation and for the tool. It looks really amazing and should save a lot of time on my side. I was just wondering, can we use it as a pickle with extra step, meaning that we don't need to load the object first or define the object first before loading it? Does it work with, does it work with all objects? Like if I don't know, if I define my own object and I MLEM save it, can I load it straight after? Or is it working only right now for sklearn and PyTorch and big framework objects?
Yeah, for now it works only with, as you said, with big libraries, and we have a list somewhere. But we have an issue to support like external unknown formats. Basically, it will work like MLEM object, but you need to define all of the stuff that MLEM finds out automatically yourself, like requirements, the methods, and how to save and load it. If you want to. If you don't want to, you can not define it, but then you wouldn't get all the features of MLEM. Like you can't serve the model if you don't know what the methods are. Yeah, and also important thing to note that we support regular Python callables. That means that if we don't support some model framework, we can just you can just wrap it up with some Python function, and this should work. Basically, we might be using Pickle for that, and maybe this framework has its own better optimized way to save the model, and we will use Pickle instead of that. But otherwise, this should work perfectly.
Okay, thanks.
Thanks, Alex. Dror has a question too. Go ahead and ask your question, Dror.
Thanks. Thanks for the presentation so far. And my question, I think, relates to the previous one, namely, if I train and persist a model that is a scikit-learn model, for instance, and I serve it, and the predict endpoint is the one used for predictions, right?
Yeah.
With other frameworks, it might be that it's another function, right? And then if I think, so it will be, I don't know, not predict, but probability predict or something like this for another framework. And then I change the model. So I start at first with one model, and then I serve it, and the API is served on the predict endpoint. And then I change it, and it's actually another endpoint that I need to use. Is the tool kind of normalizing this? Where is it getting the names of the endpoints, in other words?
Yeah, okay, I got your question. So we both normalize the names, and we keep the original ones. That means that we have a predict method, and it has fixed signature, like the first one argument named the data. And we also keep all the original methods, but their name will have the prefix like sklearn predict or something like that. We will see that in the demo. So the predict endpoint will always have the same signature, except for data type. So if you're using the same set of features for your model, you will have exactly the same signature. But if you change the frameworks, the additional methods will change. So you had sklearn predict, and you will have 𝗺𝗵𝗺𝗺𝗃 predict, for example, which might have different signature and different argument names and so on.
Thank you.
Yeah. Okay. So let's do we have another questions, or can we go to?
Yeah, actually, maybe a quick one. Hi, and thank you for the presentation. So I was process, more specifically, like in relation to the requirements. We saw some some other frameworks like Bento decided to use like specific requirements pre-specified during the packing process, because they cannot identify the requirements based on from the script that actually is the model, right? So is like, are you doing something different, or is the process which defines the requirement of the training or like of the model itself at least somewhat brittle, or like can we expect that like custom packages, or let's say like packages which are installed from like private PyPy repositories will be handled let's say like not perfectly, at least in the first iterations?
Yeah, I didn't hear some parts of your questions, but I think I get it. So you're asking about how we basically collect the requirements. Yeah, we have like very complex code for that. And of course, we collect all the requirements that are installed from some PyPI repository. For now, we don't know about private repos, but we definitely should add this, I think. Yeah, and as for custom code that you wrote, we also collect it, and we keep it with the model metadata. So if you use some Python script to write the code that your model uses, it will be added into the metadata of the model. And if you need to run it, you have you have some method that will like extract this code to your working directory, and you will be able to load it. I hope I answered your question.
Yeah, definitely. Thank you.
There's a question from Francesca.
Hi. Yes, a short question. Do you currently support only basically supervised learning, so model.predict? Or, for example, do you have also the possibility of supporting, say, a recommendation system model where like you predict probability, but then you have really recommend, say, top N items?
Yeah, for now, we just don't support frameworks for recommendation, but that doesn't mean that we can't. Basically, for each framework, you set the model methods names in that implementation. That means that if you have some particular framework in mind and it has like not predict methods but recommend methods or something like that, in the implementation of MLEM kind of wrapper for this framework, you can say that, yeah, this object has recommend method, and after that, the rest of MLEM will work with it, and you will get like endpoints and stuff for this method name.
Okay, thank you. So basically, it's not currently there, but nothing excludes it's in the extension to it. Okay, yeah, thank you.
Okay, so this demo is just a notebook I prepared, and for now it's running from scratch, so we don't have anything here. Here's the requirements that we need for this, and actually this notebook is in my GitHub, and I can send you the link if you're interested later. So the first step, as I said, we just train the model, and we will use the load iris, which loads iris dataset, and train a little random forest classifier, which is really small and fast, but that doesn't matter because we're showcasing MLEM, not scikit-learn. Yeah, and we are going to start with saving the model. And as I said, we don't need, oh no, the data is pandas data frame, just so you know. And we're going to save this model using MLEM. For that, we're importing save method and running it. So here we provide the object that we're saving. This is the path. Sample data is required for MLEM to know what type of data the model expects and what type it returns. And some description, which is optional, of course. And actually, say have a lot of other arguments, but I can't bring the help up. Let's do it like this. Yeah, but we won't cover it here. It's all in the documentation on MLEM website. So what we got after we saved the model, we've got two files, as I promised. One is the binary and one is a YAML file. We can take a look at this YAML file. Yeah, and it has all the information that we need to like reproduce this object in some other environment, we can see the same information here, because this YAML file is actually just this model object serialized, because this object is actually a pedantic object. So yeah, we have this description string here. We have a set of artifacts, and this one has only one artifact, but there could be more. We have the requirements here extracted, and we have this big model type field, and this basically has all the information about the framework that you used, the methods, the signatures, and the way to load and save the model. We'll see it shortly. So yeah, and that was the MLEM file, and the binary file is just a regular pickle. I will prove it to you by loading it with pickle. And actually, the artifacts field in the metadata can be used to open those files. If you, for whatever reason, need to open the files without Neum. Yeah, and this will get you the same object, of course. As for requirements, you can see that this provides like the string for pip install. You can do something like this. Oops. Yeah. And for now, there is no such method, but there is an issue, and we're going to add a way to like reproduce the environment with the one MLEM CLI command, like MLEM create env something, and it will use all the requirements of some model. Yeah, and as for model type field, as you can see, it also very big as Python object. It's also a pedantic model, so it can be serialized with dict method, and it has first it has the original model object in the field model. It has IO, which is like a way to save the model, and here for scikit-learn we use pickle, as you saw, but for other frameworks that might be not pickle but some custom implementation, for example, for XGBoost and CutBoost and 𝘊GBM, we use their own implementations of saving model. They have like model.save or something like that. I don't remember. Yeah, and also model type has the methods field, and this is a dictionary with all the methods and their signatures. So we will get the signature for predict, and it's described as like the name is predict. It has some arguments. It returns this. For example, the first argument is data, and we can see that this should be a data frame, and it has should have some columns like this list of columns, right? Basically those columns. And this model returns NumPy array, and the shape is none, which means that it's like a 1D array. And yeah, if we call predict method with data, we will get this 1D array of predictions. Yeah, as I said, we can save not only models, but data also, and this is done with the same API method. So we will get slightly different metadata from data, because it's data, not model. We have the same like description, artifacts, requirements stuff, but we also have the reader, which is like metadata about how to read the file, this binary basically. So yeah, let me show you that now. We have the iris CSV and iris CSV.mlem. And of course, .mlm file contains this information in YAML format. So yeah, we have requirements for pandas. It's obviously just pandas, and the reader tells us that the format is CSV and which type of data we should get, and it's the same type that we have in the model as a data argument, of course, because it's the same data. Yeah, and the file that we saved is basically a CSV file. And we can check that it's the same data, of course, and it's available under the data field of this MLEM object. Yeah, now I want to introduce this concept of MLEM project, and basically this is this is a directory with .mlem directory inside it, and this turns your directory into a model, into a MLEM project, and it has some different logic for saving files, and I will show you what is different. For now, we'll just remove all the previous files and start with MLEM init. This creates MLEM project in your directory, but actually what it does is just creates this MLEM directory with the config file. And for now it is empty, but you can set some configuration options. For example, you can set default format for saving pandas data frames with this CLI command, and it will say that this is okay. And now if we save the model and the data, we will get first it will be saved not directly to your directory, but inside this special .mlem directory. So now the iris data is inside this MLEM data iris, not just iris if we didn't have the MLEM project. This is to get some structure to your MLEM objects. But if you don't want to save your objects inside this MLEM directory, there is a flag which is called external, and if you set it to true, you will still save your files to the same exact location that you provided for save function. Yeah, and since we set the default format for pandas to Parquet, now we can use Parquet to read the file. And of course, if we use CSV, it will fail. Yeah. Okay, so that's all about saving, and we get to the good stuff about what to do with your MLEM object after you saved it. And for that, we have, again, CLI and API. And actually, most of the CLI is just calls to API with some wrapping for CLI purposes. So if you want help on CLI, you will call MLEM-h, and for each command, of course, there is help. Yeah, and you can see the list of commands that we have. And if you import all the API methods, they're pretty much the same as those, right? So for example, CLI command MLEM-ls shows you the contents of your MLEM project, and there is ls command in API. Yeah, so the first thing you can do with your MLEM object, as I said in the presentation, is load it. And for that, we have two methods. One is load, and this will get you exactly the same object as you saved. In our case, it will be random forest classifier or pandas data frame. And we have load meta, and this one will load not the exact object, but MLEM object. So as you can see, if we use it with ref, we will get random forest classifier. And if we use load meta, we will get this object. Also note that I didn't specify here the .mlem model, because if you have MLEM project, you can still access your objects without this prefix. Also, as I said, load and load meta support remote locations. For example, we can load some model directly from our get started example repository in GitHub, and we can even set a revision that we want to use. Actually, since I copied the code for training from this repository, we'll get the same the same model, because it's also a random forest classifier for iris dataset. And yeah, we loaded the meta file, MLEM object, and it has fields like location. Actually, this one also has location, but it's nothing interesting. It's just my local path in my local file system. But this one has like a GitHub URI and so on. And inside we will find all the same metadata as for our local object. And to get the actual random forest classifier for that remote MLEM object, you should call these two functions. This will load the object, and this will get you the value. Of course, you can go to model type .model. It's the same object. Yeah, and here I wanted to show you that it doesn't have all the methods of original object. For example, you can't feed a model, model, but it will have the methods that original object had that we know of. For example, it has predict robber, or it has predict, and you can call it directly on a remote ref. This. Yeah, this works great. Next thing is applying, and as I said, it's all the same as just loading and calling your methods like this, but it is also available from CLI, and it is available if you have your data that you want to analyze your model saved with MLEM, or it can be imported in MLEM. I didn't say anything about importing yet, but basically there is this MLEM import command and also API variant of it. And this means that if you don't have MLEM object, you can try and create it on the fly if we know how to do it. For example, if we see that this is a CSV file, we can try to read it with pandas, and then we will get MLEM object from it. If we have pickle, we can try to pickle it and get the same metadata from the live object. But of course, it's more limited than just having the object trained in your script and then saving it. Yeah, so here we apply it to the iris, which is saved data frame, saved to Parquet. Yeah, and we can run it, and we will get some JSON with the answers, which are the same, of course, because it's the same model. Yeah, and of course, it works with the remote objects too, so we can run apply and we need to copy the model locally. Of course, it works a little bit slower because it actually loads their model from GitHub to memory. Yeah, but you don't need to first copy it to your local files, something like that. And of course, it can be, for example, S3 URL, not GitHub or something like this. Basically, anything that 𝘊𝑆pec supports, and we have some URLs that we support extra. For example, those GitHub URLs are not supported by 𝘊𝑆pec, but we do support them. Yeah. Next thing is serving, and of course it has API like this. We will use CLI because we don't want to run fast API server in a notebook. Yeah, so for serving, you need to specify some options. They might be required, might be optional. To get the list of options that are available, first, to get the available implementations, you can run MLEM types. If you run just MLEM types, you will get all the abstractions that we have. There are a lot of them, and we're interested in serving, so we'll go with server. And those are available implementation of server. For Heroku is a specific serving for Heroku, so we won't use that. We don't have an ARM-queue, so we'll go with fast API. And it has two options for now. It's host and port. We probably should add more, but yeah, we just don't know in which scenarios which are needed, so we will add them later. Yeah, let's try and start serving with port 18, right? So MLEM loaded the model and spinned up fast API, and we can go to this URL, and we will get the OpenAPI documentation, and as you see, we have the predicted here, 𝗶𝗺, and also those are original. Check out that this has data values, and then all of your data frame columns, and this one has X values and all of your data frames. So scikit-learn expects the first argument to be X, but our common signature is data argument. Yeah, and here you can even try it out. You can send this payload, click execute. You will get the response, and yeah, you can change some values here, and you will get different answer. Also, it has like a curl. Then you can run. That means you of course you don't have to run all your queries here. You can do it programmatically via curl or via some code. And actually, MLEM has this client class, and I will show it later when we deploy it somewhere, because for now this is like busy with running the server. Yeah, as you can see, those are our requests, two requests. Yeah, and we can create client for the server, and it will have this predict method that we will feed it data, which is a data frame, and we will get the NumPy just like it was local. Okay, let's stop this to follow. Yeah, next one is building packages, and for that we have build method in API, and we of course have the build CLI method. To know which type we support, you can call this command for implementation. For now, we have two Python packaging implementations, which is VHL, which builds a wheel file, and we have pip, which just creates a directory with your package. And the same for Docker. Docker builds an image, and Docker tier will create directory with your image context, like Docker file and all the stuff. So let's try and create a directory. You can see that required options are server. This is the server that will go inside your image, and target is a path where we would save the files. So we run this API method build, and let's see what we get. So we got this build Docker directory, and we have the Docker file, the model itself, requirements, and run.sh. Requirements, of course, has all the requirements for model, and also requirements for server, which is the FastAPI and 𝘊𝗃𝗃. And the Docker file is like a regular Docker file. It has like Python base. It installs all the requirements, including MLEM. It has some environment variables for MLEM to work. And yeah, it runs the sh file, which is just MLEM serve model with FastAPI. And this will run the same FastAPI server like we saw here. Okay. Yeah, let's also try and build some wheel file. For that, we need to specify a package name and also target, which is directory. We can run it. It takes a bit longer because it actually builds and zips the wheel file, and we will get this wheel file here. We can even install it and import it, and it will have all the same methods as your model. Yeah, okay. So the last thing, sorry?
We're coming up on time, so I just wanted to make you aware of that. Sorry to interrupt. But
Yeah.
we can go long, just wanted to address that we're coming up to the hour. We do have one open question, so however you want to go. Dror has a question, so I just wanted to make sure if he needed to go, because we're coming up to the end of our hour, he got answered.
I can wait.
Okay.
Okay, that's fine. We as a team have like a hard stop at like 8:14 because we have to get to an all hands meeting, but we can keep going. So that's fine.
Okay, so let me just quickly run all this stuff. Basically what happens is we declaring an Heroku platform, deployment to Heroku platform, and then we run it. And it may take some time because it actually builds a Docker image. And while we're waiting, I can answer some questions and we'll finish with this. Okay. Yeah, so what are the questions?
I have a question. So earlier in your demo, you saved the data in two ways. Once when you saved the model and there was the sample data, and then you also saved the data directly. First question is, under the hood, it's the same data, right? That's stored. The sample data in the model saving and the one that you save directly, it's just two copies of the same data.
This sample data is not saved actually. It's just used to extract the type of the data. So if I just run this, I won't get the data anywhere. I will get the metadata about this data, right? The columns, the type, and stuff.
Yeah.
And when I use save for a data frame, I will have the CS file with this data.
Yeah, okay, got it. And then the second question exactly regarding this cell, we see now number 28. this kind of saving the data, if you can say something about how it interacts with DVC, because here you actually really start saving binaries, things that you probably don't want to save in your Git, not to have large files there. If it can still fit into the scope of this demo, not, we can continue on this.
Yeah, I can answer that quickly. So basically, to work with the DVC, you need to specify your storage as DVC. So this is MLEM config set core storage type DVC, something like that. And from that, MLEM will know that you're using DVC to save your binaries. And after that, when you're saved, it will be saved locally as you would expect. But after that, you can actually use DVC to DVC add and DVC push and all the DVC commands. Yeah, and if you push it to, for example, GitHub repository, you won't get this file in the repository, right? Because it is saved in DVC cache. But if you try to load this with MLEM, MLEM will know to look in DVC cache when you're trying to load this. So we try to avoid like running DVC commands for you, even if you want to store your models in DVC, but any models or data files or anything else. But we are aware that you stored your binaries in DVC, and we can load them from DVC cache.
Thanks.
But
I can ask if you can hear me now.
Yep.
Yeah.
Okay, awesome. I'm still like wondering about the requirements. Like more specifically, I'm interested in how the Python version is being defined, right? So, for example, if I train a model using Python 3.7 or something, and my CI/CD process runs the build step using a different version of Python, which one of those is used in the resulting Docker file and the image?
I'm not sure. We should see in the Python version in the metadata, but I don't see it. So
well, yeah, you don't, right? But it's being created in the Docker file, right? You need to specify like a version of Python there.
Yeah. So this Docker file that we created, it uses the same version as your Python that you are using to run this command, right? Right, this one. And where's the Docker file? It is here. Yeah. Yeah. So if you're creating the image from different Python version that your model was trained in, the metadata of model should know the version of the Python that you use to train the model, but I don't see it right now for some reason. But it should be in here, and now it's empty. So that's a bug probably.
Yeah,
but
I get it, right? So it's like it's packed within the requirements, whether it's like shown here or not.
Yeah.
Besides the point. Okay, awesome, great. And the second question is kind of like I'll ask it on Discord. It's probably like a long shot anyway.
Okay, we have a question from Thomas. Thomas, do you want to ask your question?
Yes. Can you hear me?
Yep.
Yes.
Good. Well, first, thank you for the presentation. I had a quick question regarding the pre-processing, because sometimes, like from what I've seen in your demo, like how or where should we if we have to, I don't know, like clean some text, sorry, before the predict function, is it planned or supported, or how to do it?
You mean some pre-processing for your data?
Yeah, right. Yeah.
So, yeah, actually, we, as I said, we support Python callables. So you can either use extract your pre-processing into a function and save it as a model, or you can actually make it a part of model. So where is it? So if here you will like say something like this, and you will do, I don't know, what are like this. I don't know if it works. Let's try it out. Yeah, it works. So now you can actually save the function. I don't know, ref2. And it doesn't work for some reason. Oh yeah, we forgot the sample data. Yeah, and this will have your pre-processing inside the inside your model, basically. So your model will be pre-processing with the actual model.
Okay, thank you.
Just concerning this example, thanks again for the presentation and for the demo. I wanted to know, like, is it possible to have nested import? Like here, if ref is not defined, like to define it there, to load it there.
Let's try it out.
And not especially with like,
work?
no, more like MLEM API load inside. Like if in my model I want to have pre-processing, inference, I would say, and post-processing, is it possible to load the model in this function literally?
You mean you can so you can
define
do
ref,
it
for example, inside.
Sorry, I don't get you. You can do it like this, and you will you can do, I don't know, something like this. And here you can do this, and it will work the same way. If you're asking about this kind of nested functions, of course, if you're asking about imports, they are there will be collected also.
Maybe it's a dumb question, I'm not sure, but it's more about the RF model here. Like if I send that to my client, let's say, the RF object will be saved in the my model ML object.
Oh yeah, of course. Actually, since it is a pickle, we use pickle for callables. So this ref object will recursively be a part of your model, and it's called closure, I think. So yeah, this object will get there, of course.
That's dope.
Cool. Okay. All right. Well, we should probably close up since we went long, and our team has a meeting to get to too. Thank everybody for being here. Thanks to Mike for his amazing presentation, to Alex, and also 𝗵𝗺𝗪 who has worked on the project. Please, I put a ton of links into the chat. Collect those, get them, join us in Discord if you have more questions as you try this out. And definitely open issues. We would love to add more frameworks for you and ways to deploy. So open those issues so that we know what you need so we can get it done for you. Thank you all for being here, and we will see you on Discord in the meantime.
Thank you, everybody.
Thanks.
Ciao, thank you.
Thanks,
Bye,
Alex.
everyone.
Bye.
Thanks, Dror.